Have you ever looked at a massive skyscraper and just wondered, how did that start? How does something that big and complex begin as just a simple idea in someone's head? Well, today, we're going to pull back the curtain on that secret life of a building's design. We're talking about that whole process before a single shovel ever hits the ground.
I mean, really think about it. How does a thought become a skyscraper? An idea become a home? It feels almost like magic, but it's not. The answer is in a supercritical, really layered process called preliminary design. It's basically where the dream meets the drawing board and where all those big, grand ideas get their first real-world test.
So where does this whole journey even begin? You might think it's with a sketch or a model, but no. It starts with a conversation. Every great building, whether it's an office tower or a house, starts by answering a really simple question. Who is this for, and what do they actually need?
And that brings us right to ground zero, the client. Before a single line is drawn, architects and engineers spend a ton of time just listening, trying to understand the vision, the budget, and the absolute must-haves. You could say this initial feedback is basically the project's DNA.
But, it's not just about what one person wants. A building doesn't exist in a bubble, right? A really smart design has to think about the everyday people who will be using it and the community that it's going to become a part of. Does it fit in? Does it serve its neighbors? Getting that feedback right ensures the building actually has a purpose that goes beyond just its own four walls. Okay, so once the why is all figured out, we can finally move on to the what. This is where all those conversations and requirements start to get a physical form, built up one layer at a time. The whole process is actually layered, a lot like the building itself. First, you've got the site layout. That's where you decide exactly where on the plot of land the building is going to sit, how you'll get to it with roads and paths. Then the architects literally design it floor by floor, starting with the ground level and just working their way up, making sure the whole thing flows logically.
And each one of these floor plans is like a detailed map of the building's anatomy. You're defining the usable space with rooms and halls, figuring out how people will move up and down with staircases and elevators, placing essential things like restrooms, and making sure it's all connected to the outside world.
Now here's a really crucial point. A blueprint is so much more than just a map of walls. The design at this stage is also about the human experience. What's this building going to look and feel like? How does someone in a wheelchair get around easily? If there's a big meeting hall, can the person in the back hear what's being said? These high-level features are what turn a functional box into a truly great piece of architecture.
Okay, so we've got the layout, we've got the look and feel, but what actually makes it all work? Now we have to design the building's hidden engine, all those complex systems that are going to bring this structure to life.
The best way to think about it is that a building has four main interconnected systems. They're its beating heart. You can see from the chart that the structural system is the biggest piece of the puzzle. It's the skeleton. But that skeleton is useless without the others, the electrical, the plumbing, and the HVAC systems. Let's break down what each one does. First up, the structural system. This is literally the building's skeleton. Engineers are doing incredibly complex calculations to make sure it can hold up its own weight, plus all the people inside, and even handle things like high winds. This is the absolute foundation of safety. No compromising here.
Running all through that skeleton is the electrical system, which is kind of like the building's nervous system. It's powering everything, from the lights above your head to the really critical emergency systems that have to kick in if the main power ever goes out.
Then you have the plumbing. This is the building's circulatory system. It's constantly managing the flow of fresh water coming in and waste going out. It handles everything from the sinks and toilets to the fire sprinklers.
And finally, the HVAC system. This is what breathes life into the space. Think of it as the building's lungs. It controls the heating, the ventilation, and the air conditioning to manage everything from the room temperature to the quality of the air that everyone's breathing.
So at this point, we've got this beautiful, functional, incredibly well-designed plan. It's perfect on paper, but there's one giant question looming over everything. Could we actually afford to build this thing? And what could possibly go wrong? This is the reality check.
First things first, the raw materials. Every ton of steel, every pane of glass, every truckload of concrete, it all has a price tag.
The design team has to put together a preliminary estimate for every physical thing that goes into the building. Second, you have to pay for the expertise. This isn't just about materials, it's about people. We're talking wages for the whole team, from the architects and engineers who dreamed it up to the construction workers who will eventually put it all together. And third, you need the tools for the job. You can't build a skyscraper without cranes, excavators, and all that other heavy machinery. And that stuff doesn't come cheap. So whether you're renting it or buying it, that's another huge piece of the budget.
But look, a budget is just a forecast. A really good plan also prepares for things to go wrong. The team will identify the most likely risks, like the budget going over or construction getting delayed. And then they'll build a strategy to deal with each one, like having extra money set aside or backup suppliers ready to go. It's all about planning for bumps in the road.
Okay, the design is drawn, the systems are engineered, the costs and risks are all laid out. There is just one final hurdle to clear before this preliminary design gets the official stamp of approval. And that's the compliance check. This is the moment of truth. This is where an independent check confirms that the design isn't just a cool idea, but that it's safe, it's stable, and it's legal. Getting this passed means it's ready to move to the next stage. So what are they actually checking for? Well, it's a pretty long list. They're digging into the structural analysis reports to make sure it's stable. They're making sure it follows all the local and national building codes. They're checking fire safety and evacuation plans. They're even assessing its environmental impact. It's a top-to-bottom review. And there you have it. From a simple chat to a fully vetted, costed, and compliant blueprint. All of that invisible work is done. But this is really just the end of the beginning. The next hidden challenge? Well, it's taking this perfect plan off the paper and into the messy, complicated reality of a construction site. And that is a story for another explainer. Thanks for joining us.